Hello, Natroners, and welcome back to another episode of VFX with Natron. So, today we're going to talk about SeExpr Editors. What do I mean by EXPR Editors? Well, Natron's not the only program out there that has SeExpr. There's like Pixar has it, Disney has it, and as we've talked about before, there is a Disney editor. And most recently, the newest addition to SeExpr editors out there is actually Krita. Krita has added this in their newest, well, apparently it's been around since version 4.3, or at least that's what the documents say. But I only recently found out that it had it within the past week. So I wanted to also, because that's available, I figured, and it's of course platform, I thought we would take a look at that as a thing. And joining me again today for the umpteenth time is our special guest and my favorite Esquire, who's not actually an Esquire in this episode, but he's still here, Mr. Tom Morley. Hello, Mr. Tom Morley.
Hello, how you doing, Pirate Bill?
I'm doing pretty darn well today.
And how's Natron Land?
Oh, Natron Land's pretty good. And today, I'm just going to say this is going to be a little more of an interactive format. We sort of did this with Chris Charlton last week, where we had a bit more back and forth. And I feel like I want to do more of that this time. So, Tom and I are going to discuss this. We're going to keep up things. For right now, we're not going to hop over into Natron per se. When we get start talking about a specific editor, I will try and pull up the editor. But for now, Tom, do you have a particular favorite SeExpr editor or any SeExpr, tips and tricks you enjoy?
I'm eagerly awaiting your demo of the new editor, because it's really cool that this editor, I think, has auto completion.
Yeah,
I think.
It has auto completion, and we'll actually look at. You know what? Because we're talking about it, I did say Krita has this. How about I switch over to that right now? And let's see. We'll go over here. Let's see. I've got it right here, and I've got Tom. Tom is on the corner down here. I might. All right. I gotta adjust my thing here so I can temporarily move you out of the way, just in case. And if I'm going to also give you a task if you're up to it. Whoa, whoops, that was a mistake. I accidentally clicked something. I'm sorry, everybody. That was from last week's residual.
Halloweeny.
Yeah, that was from last week. All right, I'm just going to move Tom out of the view for the moment so that we can look at Krita. All right, so we've got Krita, and the biggest problem, I think, with Krita, I keep doing this, I've got to remember in my setup, I have a little monitor over here that shows me my focusing and so forth, and it's very distracting when it's on. I keep looking at it as opposed to the camera. So anyway, sorry, I'm back to this. All right, so the biggest problem with Krita, or the biggest hurdle for a lot of people regarding Krita, is that it's not obvious how you get into it. So that was one of my big things that I wanted to show people. This is the beta number 2 of Krita, which has an SeExpr editor in it. And so what we're going to do first is we're going to double click on this new file option here, and we're just going to create a new document. All right, and then over here, once it creates the new document, over here on our right, we have our layers menu. And on our layers menu, next to the plus to add a new layer, there's a little arrow for a pull down, and there's all these different types of layer types you can add to Krita. And the type of layer we want to add is a fill layer. When we add a fill layer, it pulls up this little dialog here. And you'll notice in this dialog, it has a list of types of fill layers that we can do for this, and right down here we can see SeExpr, and that opens up the new SeExpr editor. And as you can see, as soon as we do that, it opens up the very same one that we find if we go over to the Disney editor and we click on, I think it's like one of the, here we go, this one right here. We have this exact same pattern. So we can see this particular Disney pattern works inside of Krita, which is really exciting. This also works inside of Natron, which means that we could potentially, and I'm going to just let you guys in on a secret, these all don't work completely 100%. They're not all compatible. One of the things about SeExpr is every interface has its own set of parameters that you can add. Even Natron has their own. We have a thing called CX and CY. Those don't exist in either the Disney or the Krita editors. And to be honest, I have no idea exactly how we could add them to them by default. And Mr. Tom Morley, could I ask you to cut back on your typing?
Oh, sorry.
Your typing is very loud.
My big fingers.
It is coming over on your mic. So anyway, not trying to be, it's just loud. All right. Where were we? We were talking about this. So, we can see the editor. And one of the things that's really nice about, one of my big gripes, I should say, about, what just happened? I just lost almost everything off of my other window. I don't know what just happened. One moment, I've got to reset a bunch of things because I've lost people and things. There we go. I need those up, and I also need our chit chat going on the stream. Today's going to be one of them days. All right. Yes, as I was saying, one of the things I really like about the Krita editor over the Disney editor, and I'm going to pull up the Disney one for a second. The Disney editor, the biggest problem I have, besides being what we'll say the big pro to the Disney editor is it can be run on any platform. The biggest con with it is that it has to be, because it's a Windows specific program. In order to run it on Mac or on Linux, you have to run it in Wine, which means you have to install Wine to get it to run. And then when you run it under Wine, you don't get this nice little list of the stuff. You can load all the scripts. They're just text files that are saved in a folder with this. But they don't come up, at least I didn't find they came up for me in my version of Linux. The examples, they just didn't come up with it. And some of these are also designed specifically, the Disney ones are designed to work with a PR man, render man, so they're not 100, which does a lot of 3D stuff. So there's a lot of specific stuff in it that doesn't necessarily directly translate into Natron. And we went over, for example, one of the big ones that we needed to solve to get stuff inside of the Disney editor to go into Natron in the past was the $P. Unfortunately, guess what? Want to take a guess? Oh, hold on, let me pull you back up. There you go, you're back up, Mr. Tom Morley. So, want to take a guess? One of my biggest gripes about the Krita editor right now is...
It has no $P.
Boom! You win yourself a cannonball. Shall we cannonball? We're going to cannon... Let's cannon... We're going to cannon Krita. We can cannon Krita. All right, let's get over the... Let's get back over here, and let's put you up onto the screen with me so we can watch this together and enjoy... Just bask in this. We're going to blow up the Krita for that one. You don't support $P? How bad are you? Actually, it's all can't really. All right, back to the.
So, what do we think the reason is for that? Mainly because it's not a 3D program. You think maybe?
I that's one of the things that I was puzzled by. Now, here's the really weird thing. The editor or the documentation. All right, I'm going to tell you the biggest pro. The biggest pro, in my opinion, besides being cross-platform, which means this opens on all of them, and you get code completion and all the demos. Let me just quickly pop over quick See, if we go over here to this tab called Scripts, it has all these really neat demo or like samples over here, and we just click on them, and it's nice because these are actually pre-rendered stuff, and when you save them, they do it. But when you click on them, and it actually draws it, so you can get like a really nice zoomed-in version, and that is fantastic. And to me, that made this really exciting when I first started playing with it. But there's a lot of flaws with this at this time. But the biggest, it's new, and admittedly, this version is, as far as I know, still in beta, so it has a lot of potential to grow.
You know what that reminds me of? That reminds me of the GL SL Playground. It almost looks exactly like, you get the tiles of all the different effects, and you can just click on them, and then you'll see the code. So, very intuitive. I like it.
Yeah, I like it, definitely the strongest point, and it has this is a real strength of both the Krita and the Disney editors that Natron really lacks, is that they have these interactive controls when you're dealing with the C curve. You can do this. You can like grab these and pull them around. I'm not going to do it on the Krita one, but I'll do it in the Disney one because I know the Disney one always resets. We can pull this around and change the actual way that the colors ramp across this very easily. And it's not hard to do this stuff to create or to pull these into Natron and gain access to these controls, but we don't get this nice interactive thing by default. We have to go through hoops to make it work. Which really, 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 if there's one feature I would like the Natron editor to, well, two features I really should say. Both of these have code completion in them. They're color-coded. They have real nice IDEs. We can see here, we can see all the colors of the Krita one over here, and we can see the colors of the Disney one right over here. And they both look very similar at this point, and we get the interfaces. I wish the Natron control panel had this type of interface.
Shout out to the coders.
Wink, wink. Bye, guys. Maybe.
Especially if all this code is already out there. I mean, if they polish this and it's really good for Krita, I think it'd be very easy to just swing it right over to Natron.
Oh, I agree. I 100% agree. I think that could be. I'm just curious. Now, these are only two of the editors. Obviously, we have Natron. We'll pop over into Natron over here. People might have spotted that little bit of blue on the side. That's something for maybe a little bit later. Right now, we're going to just put in an SeExpr node just so we can see ours and see how utterly disappointing it is. Really, seriously. Well, our controls are literally these three things, and that's it. And we can control all that stuff, sort of, mostly, with the exception of the C curve. C curve we have to do through a Python hack, but the pro to ours is, of course, none of the other ones allow you to actually animate C curve, whereas in Natron we can. And we went over that as one of the cool secret special sauce, so to speak, because we can link it to this using Python. But we lose that. The other thing I think is a bit weird about Natron is that we have an actual separate alpha script, whereas most of the other ones deal with this stuff in a sort of a pre-multiplied state, whereas Natron, by separating the RGB script and the alpha script, you can either deal with the textures as unpre-multiplied or pre-multiplied, and do some really, you could have totally separate scripts, which makes it kind of interesting. But my big problem is they really don't give us a way of enabling or disabling that by default. We literally have to build it into our code to take advantage of the multiplication. We have to pull the alpha from somewhere. And as far as I know, there's no way to get this alpha script up into the RGB script, which to me is, it just seems off a bit. I oftentimes
maybe just gives you more control over what you can do, but with that becomes more complex. So
it is more complex.
It'd be nice to have a little check mark that just said, I want this to be simplified. Just give me everything rolled into one rather than separating it out. So it'd be nice to be able to have that.
Yeah, I agree. So
programmers.
Wink, wink, programmers. Now, here's the thing. All right. so I mentioned that Natron does not, by default, have some of the special things. Oh yes, the big thing pro to Krita is its documentation. I just wish to say, the documentation, as far as I know, only came online within the past few weeks, and or at least since sometime between the last time we did an SeExpr episode and now, when I started playing with it about a week and a half ago because I wanted to do something, and when all of a sudden I was like, where'd all this information? What's this about Krita? What? Krita has it? What's going on? Anyway, they have the documentation for Krita is really, really, really laid out nicely. It's easy to read. It's well formatted. That's one of the things that's really great about the Krita documentation. But here's the funny thing about it. The Krita documentation, 90% of the stuff that it says in the documentation doesn't actually work inside of Krita.
Oh, no.
Isn't that just bizarre? It's like, let me give you an example. All right, let me show you. Let's just pop over to Natron for 2 seconds because this is
a quick question, though. It doesn't work in Krita, but does it work in Natron?
It doesn't work in that's what I'm going to show you. This is okay. We're going to do something stupidly simple. We're going to all right. First of all, I'm going to copy something from a project I have off to the side over here. This is a little thing we're going to go into in a minute. Let's just all right. Actually, before I do, oops, I just clicked on my wrong Krita. I'm going to have another version of Krita pop up in a minute. So let's just talk about two of the variables that you'll often see in Krita documents or things. I'm going to go over to this one because it's kind of cool looking over here. It's like this purple plasma lightning kind of thing. Where is it? Don't they? I thought this one used. Why am I not seeing it? Uh-oh. I take it back. That's not the one. Let's find another one. There's a lot of ones in here that are kind of interesting. But here we go. All right. So they use this thing, and it says they do get their aspect ratio by because in Krita, their version of SeExpr has gives you the height and width of the document inside of SeExpr, and Natron by default does not, at least not to my knowledge. We deal with it in a 0 to 1 space, not in a physical resolution. So then it becomes, how do we get this information into Natron so that we can actually use it, so we could copy, say, for example, this script. If we wanted to copy this texture out of Krita and put it inside of Natron so that hopefully it will work, because there's all the things about the Krita editor that are weird. How do we get that to work? So I actually created a bunch of things. In the past, I had created a thing so that we could get $P from the Disney editor. But now that Krita exists, I've updated that, and I wanted to share this. So this is my new header, and I'm going to copy it, and I'm going to paste it in here into Natron. And this is what I call my SeExpr compatibility definitions. And you'll see that we have W equals pause 0, and H equals pause 1. And anybody who's familiar with Natron, SeExpr, as we hopefully all are at this point, we are seeing an error saying that's not right. It's throwing an error at us. Actually, that error is not really an error from that. It's because we don't have something output, which I'll put that back to 0 so it's black. All right, so the problem is that we don't have anything. There is no pause 1 and pause 0 and pause 1, or I should say pause 1, 0 and pause 1, 1. So what we do is, if we give ourselves a position parameter, because that's what pause means, we get pause 1 X and pause 1 Y. So how do we do this? Well, it's pretty easy, actually. To get Natron, what we have to do is just set an expression for each of these. All we have to do is say this node, this in small letters, and node with a capital N, which gives us whenever you see -1 in an expression editor as a result, that means you successfully typed a command in properly. How do we know this node? Well, it tells us up here we have this node, the current node. That's what we start with, all right? So this node, we want to get the output format. And by the way, Mr. Thomas Morley is the one who actually keyed me in on this. I had fought this in the early days of writing expressions. He's the one who actually figured this out for me. So we're dealing with the width, all right? And the way that the output format works in Natron, first of all, this gets the actual output format. Instead of we're calling getting it to send us back. We want the result of it. So we want it to return it. So that's why we put in the double parentheses there. Then we hit what it returns is a square. I didn't realize this at the time, and that it actually returns our ROD, so to speak. It returns the left side, the right side, the top, and the bottom of our output format. Which is the entire ROD, because our left side could be -50 or -100, or it could be +100 for all we know. There's no thing. So to get typically though, if it hasn't been altered, the output format will be whatever the default ROD is. In our case, it's here's our ROD, which is 001920 by 1080. Well, that's going to be our default one for most SeExpr nodes. So to get our width, all we have to do is tell it that we want to get the right. And then we want to do it that way. And we see that over here, I'm afraid that might have been, so we can see when I did output right, we can see that down here in the result, we got 1920, which is our width. So we hit OK, and that will put it in there. And now, pause 0, which is now getting assigned to $W, so it can match Krita, is 1920. For the Y, all we do is we set expression, and again we type in this node. Just making sure I capitalized it. Oh, oops, small out. No. Excuse me. Small get, capital OUT. PUT format and parentheses, and then we put in, now what we want is the top, because the top is the height, so we'll put in top, and then we'll put that, and we can see that that results in 1080, which is our height. So there we go. So there those two are. And by putting that in there, that means now we have defined what W and H are going to be inside of Natron. So we should be able to, with just those two things, get a good chunk of Krita expressions, or I should say SeExpr shaders to work inside of Natron. And we'll test this in a minute. I'm going to actually pull some over and we'll take a look at some of them. But let's just talk about the Disney editor, which has $P. Because we're doing this here, one of the things that this changes is, before what I had done, or we had done, is we literally created a special variable that we use to represent the height. Well, the way Krita deals with this, as I said, was that these settings, the H and W, are based off of the image size. So these change in Krita dynamically based off of how big your image is, or at least that's the way it's presented inside of Krita. So these should work, in order for these to work the same way, they should match Krita exactly. So that's the reason I set it up this way. This does mean...
Before you go on, I'm just trying to solidify this in my mind, is you wrote that other code in the 2D parameters is sort of like an interface in between Krita code and Natron, right? Because I can't write that code directly in the Krita window.
Correct.
Or in the C expression window.
The CX. Oh yeah.
Yeah.
Sorry.
Yeah.
Again.
I'm missing the terms.
Yeah, doing the thing.
Yeah.
I'm like,
yeah. The SeExpress window. You're using the 2D parameter as an interface between Natron and the code in that window.
Correct. These right here, pause 1, 0. So pause 1 is this parameter right here, pause 1. And 0 is the first of the two variables here. 0 is the first parameter, and 1. So we're getting...
Which is pause 1x up there.
Correct. This is pause 1x is this first one, which is 0. And pause 1, 1 is y, which is right here. And that's why we put those two things in, which give us, as we can see, it says, not. It actually, we can't read the whole thing, but it says 1920, and this says 1080 here. So what this is doing is by filling those in with 1920 and 1080, it changes it. Now, what that also means is that if I change my project size in my project settings, which is currently behind me because I have this set up, let's see. I'm going to just shrink this down, so hopefully my face is not covering this too badly. I think I'm just double checking. Yes, I can. You can still see this. The drop down's going to pop down, but we can see over here under output format it says HD 1080 1920 by 1080. And if we pull down, there's a whole list of things. So if I change this to 4K, UHD 4K, I've changed this to 4K. So what does this mean? Let's just put something in. Let's pull something from Krita. I think this one. I think this Voronoi texture. If we just grab from here down, we copy this, and we paste this. Oops, that's not Natron. Let me just make sure I copied this. All right, well, let's go back to Natron, go over here to this, select R0, let's hit paste. All right, so hopefully this has put everything in, and when I click out, it looks like everything's there. This particular texture, because Krita doesn't have a thing, this hopefully will work, and there we go. All right, so we can see, yes, this is another thing. You might have already noticed this. Want to take a guess, Mr. Thomas Morley?
I have to wait for the stream to catch up.
Yes. Well, once the stream catches up, you'll probably notice something looks a little funny.
Aspect ratio looks a little strange to me.
Does it? No, it's not the aspect ratio.
No?
The aspect ratio is correct. Or just click back, and I'm going to click back again. It's actually the colors are off.
Oh, okay.
The colors are, it's suffering from the exact same thing. Krita's using RGB.
Okay. RGB space.
So we need to plop in an OCIO color space to correct it, and then just set the input color space to sRGB.
Just like the shader toys.
Just like the shader toys and some of the other things. We chuck it in there, and now the color space, the colors actually look proper on Natron. So as we can see, this made it, even though this is using a Krita specific parameter, we have made it by, it uses H and W. We actually have an aspect ratio corrected stuff inside of Natron. That's actually what CXCW, I think CWs. Oh, now I'm crossing terms. CXCY are inside of Natron, and that comes up under the Natron parameters for this. In fact, if we pull up the controls, you know what? I'm going to just reduce. What in the world did I just do? Holy smokes! I just opened up everything, and it just like opened all these extra parameters that I'd never seen that happen before. That's a little weird. There it goes. It's displaying correctly now. It doesn't matter. Anyway, so here we can see those extra parameters and so forth. But the big takeaway, the big reason this is important to understand is right now we're looking at this at UHD 4K. All right. And the reason that the dynamic aspect of this is important to understand, let me minimize this. Oh, you know what? I'm just going to turn it away. So close the SeExpr so we can see the output format for the project settings. Right now it's 4K. When I switch it back to 1080p like so, we can see currently it for a temporary moment it remained super scaled and then it shrunk down to match the output size, because what it's doing is it's resizing the texture scale, the scalars for this texture, because Krita does this dynamically with its H and W. So I was actually telling people when we set up P from the Disney one, we were also sort of doing this, although we sort of manually did it. What I told people is, set your output size in this special variable that we had created, and then that drove it inside of P. But now, because Krita's using it, why not make it so that if they do put P inside of Krita, we have the exact same function to derive P from it for Natron. And so here is the new modified version of P, which uses the H parameter from that we have made to create our P parameter. And so what does this mean? All right, let's look at something. I'm just trying to think of the best way. You know what might be, I think the easiest way to demonstrate what's going on here is to find inside of the Disney editor a simple FBM noise. All right.
Noise, yeah.
So here's a simple FBM noise inside of the Disney editor. All right, we copy this out of Disney. We're going to just take that now. We're getting an error inside of Natron. If I paste, why isn't it showing the paste? There we go. Control V it, paste it inside of Natron, click outside of the RGB script inside of Natron, and lo and behold, now Natron's distorting this because this is working off of, this was set up to work off of UV. It's a simple thing. All of the SeExprs have U and V. But there's a problem here. This works great inside of Natron. Let's go over into Krita. Let's select all of this. We're just going to get rid of it. We don't want any of it. And by the way, one of the things that's also nice, Krita, once you get rid of something, if it has no parameters, it says unexpected error. It pops us this little error dialog down below. Watch this. Here's the same code. This should generate that grayscale pattern we just saw. That's all that's required in both Disney and inside of Natron. But inside of Krita, it's saying exception, output code. It's saying got varying float. Well, yeah, this is a float, but it's a color spike. It's a color float. It is color. There's supposed to be color information here. It's a grayscale image, but it's a grayscale with all the colors, the channels set to the grayscale value, so it should be white across the board. Now, I thought, uh-oh, don't tell me that Krita doesn't support everything, doesn't even have, we can change this if we go over to the beginning of this and put a C in front of it and tell it that we want this to be a color-based FBM, which means instead of all the channels being the same, every channel will have its own FBM pattern. If we do CFBM, by the way, here we go. Here's the code completion. We can see it right there. And notice, bum, 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 as soon as we put the C in front of it, Krita works fine. In fact, let's go over to Natron. Does it work inside of... This is going to be... Actually, let's do it first in the Disney editor. Let's go back to the Disney editor. Does it work? Does it... This is like, does it blend? Does this work inside of each of these? We change that to CFBM. I think we might have to hit apply. There we go. Works inside of Disney. So we've got two that it works within. So these both will function for this purpose. If we go into Natron, does it work? Here's Natron. And we change it. We'll put a little C in front of that. And lo and behold, when we click outside of it, of course, Natron, in my opinion, does it the best. And it works perfectly fine in Natron as well. So we can see that CFBM works just fine. It's only the FBM itself which works inside of Natron and inside of the Disney editor, but doesn't work inside of Krita for some weird and odd reason. And what's really, really, really strange is that there's a lot of these things where Krita act on the Krita website, in the Krita documentation for SeExpr, which is, in my opinion, some of the best documentation I've found on the subject. So read it, because it really is good for Natron. It actually lists this. It lists an FBM, and if you put it in, it doesn't work. In fact, the only way to get the FBM to work inside of Krita is you actually have to jump through a kind of a hoop, or at least I think you do. As far as I know, there's a hack. Let's do a little hack.
I'm thinking that it's just not implemented yet. It's got to be.
You would think
that has to be it.
But it recognizes this. It recognizes this FBM pattern if we put it into something else that is typically color based. For example, I think if we did let's just try. No. I'm just trying to think of this. All right, let's see. Here's a simple one. Let's do a box step. Do you know what a box step is? Have you ever dealt with steps? We haven't gone over steps. Oh,
not yet.
All right.
I mean, I know what they are, but
I'm actually cheating. That actually was on my list of things to do today. Was to talk about steps. As long as we don't go too long, which we haven't gone. We're only about 30-40 minutes. We're just over 30 minutes into this. So there's this thing. I wanted to make sure that there was some new content in here for people. In addition to, chit chat. Has anybody joined the channel, by the way? Do we have any chat going on?
we have 4 people in with us now.
Oh, cool. Is anybody asking anything?
Okay. Nobody's asked a question yet. We can say
questions? Hey, if you have questions,
hello to everybody.
Hello everybody. All right, I'm going to maximize my window just temporarily so I can see all the people. Well, I don't see any chit chats. I'll see I'm not going to pronounce these names because I will absolutely.
Say hello either, but let's say hello to
hello everybody. If you have questions, ask the questions and we'll try to answer them. Because again, this is supposed to be an open chat. I want people to interact and ask questions about these if they have questions. But for now, I'm going to just bring this back down. Tom will tell me if we got anything. What I'm going to talk about. These should work. So there's these things called step modifiers inside of SeExpr, and we have them in all 3 versions. I believe I actually have not verified that this works properly inside a Krita until I might be shooting myself in the foot here. But there's this thing called a box step. In fact, there it is. It says when I start typing it in, it says box step. So I do box step, and it wants to do. We need to enter 2 parameters inside of a things. It wants 2 floating points. So our first one is going to be our FBM, which is this first thing, okay? And then we're going to take this FBM and we're going to multiply it by a point in space that is going to be our. This is the transition where the box step is going to happen, and I'll try and describe this better once this is done. I'm going to use for our box step point 0.5, which is basically. Because it's floating point, it's expecting between a number between 0 and 1. So 0.5 is a 50% box step value. So I hope, and nope, it's saying this does not have a definition. Are you kidding me? Did I? It's just no. I see what happened. It's the text is a wee bit small on my screen. It actually says box FBM step, which is not the command. It's box step.
Yeah.
There we go. That should hopefully work. It says expected the script to output color got a varying float. Huh? That's odd. I thought we could.
CFBM.
Does this work? Nope, it doesn't work that way. Well, let's try this. Let's try doing. All right, so we know that CFBM. Whoops, we can do V. That's a different thing. CFBM. There we go. All right, so it's not working there either. It does work. I think it's. Okay, here's a weird thing. If you actually start going through the scripts for Krita, currently the vast majority of them are built off of C-curve, which is probably honestly, it's cool, and because Krita is mostly a static image program, although I would argue it's not, because it has animation features. We all should know that. It has 2D animation in it. But from a standpoint of a still, C-curve doesn't matter that much, because C-curve cannot be animated in most SeExpr variants, including Krita. So, and it gives you those nice controls. But the problem is that in Natron, we can vary these things. And in fact, I encourage people, we want to be able to animate. And that means that Krita isn't, in my opinion, the best editor in its current state. Even though we have it and it works and it's cross-platform and it gives us the code completion, and it even gives us code completion for things, because it doesn't give us actual correct results inside of itself, that kind of limits it a bit, in my opinion. However, I will say this. You could, take these things, and you could have both the Disney editor and the Krita editor on your system, and you can see the results inside the Krita editor, inside the Disney editor. But at that point, it's like, well, why not just, complete it inside the Disney editor in the first place? Because if we take this same thing, let's just take this and put it inside the Disney editor, which we know, the only thing that's going to be missing on the other two, on Windows and Linux, is going to be these examples, as far just in this convenient dialog. But if we put this box step in here and click out or hit apply, I think, there we go, we hit apply, it does the exact same thing. But watch this, if we remove that C, so we do it and we hit apply, we get the black and white version, which works inside of the Disney editor. So we can see that makes the Disney editor more complete and more accurate. Let's take it into Natron. Let's take these back into Natron, go over here, pop this in here, we click over here, and what does this do? There's the same thing. That's it functioning correctly. Of course, this is not aspect ratio corrected, and if we do the CFBM on here, Natron will also do our CFBM. So Natron really still is, in my opinion, king. But I'm wondering if people are seeing what this box step is doing. Does anybody want to take a? Do you want to take a guess at what it's doing, Mr. Thomas Morley? Or does anybody in the chat? Let's
see if anybody wants to answer that in the chat.
Anybody want to try and take a second?
Well, and while they're doing that, if you go to the chat window, there's an example of a smooth step, some smooth step code in there. So if you want to bring that up.
Smooth step.
While we're waiting for people.
I'm trying to find the smooth step.
It's in the comments. Almost near the bottom.
Comments. I see step example, but then it says
just before that, where it says my Facebook.
Oh, this one. All right. Let me open in a new tab. I'm putting that into a tab, and oh, you want this pulled up as a video?
Yeah, you'll see the usefulness of what they are.
Oh, you said. Oh, all right. All right, I'm gonna pull this. We're gonna pull this up over here. We're gonna have to do a little fiddling for a minute, because Mr. Tom Morley made this a little bit strange for me. So I'm assuming it's this video here, which we'll maximize. Yeah. So we'll go over here. So here's some examples of steps. So he's showing various types of stepping. I think he's using smooth step. All right. So what he's doing is he's varying the step. And so, yes, that's smooth step. Although that still doesn't really explain it. It shows what it could be used for, but
I'm still waiting for somebody to say, what is it used for? What is it?
Anybody want to take a guess? All right, so I'm gonna just say what it is at this point, because what box step is doing is we're taking two images, and we're comparing them. And what it does is it uses one of the two images, one of the two images as a threshold variable for the other image. And anything in the other image that goes above the threshold is one color, and anything that falls below the threshold is a different color. In this case, we have white if it's above the color, or black if it's below the threshold. And our threshold in this case, because we're giving the image the import source on one side, is this FBM pattern. And on the other side, we're saying that the threshold that we're using to set it by is the value 0.5. So if anything that's above 50% value goes to white. Anything below it, or at least I think that's it. It might be doing it in reverse because the order of these does actually affect it. If you put it on one side, I think it inverts it or not. But that actually brings up another thing I want to point out. I found a little shortcut. Did you know, I didn't know this until I read this in the Krita information, that tilde is an invert function. I was like, what? Does that actually work? Check this out. If we're inside of here, if we hit, if I put a tilde here, watch this. That our result should invert. And there it goes. It inverts it. Isn't that fantastic? It's so simple. That is so useful because otherwise it's basically the equivalent of doing a 1 minus whatever. But that is really, really neat because it's a single symbol to do something that would otherwise require 2 symbols, which there's always good to know shortcuts, especially when coding things. Anyway.
Great for making a mat or...
Yeah, it's really good. So let's just, for example, change this for right now. Let's just change this from FBM, 0.5. Let's change it so that instead of being 0.5, we set it to 0.25. And we'll see that that will change this entire thing, the threshold. So now the black, as we can see, so that means that black is indeed the low point because everything over 0.25 is getting set to white. So that's what's happening here. So the black bits are getting, truncated or clipped. So it creates these speckles. And from people
show everybody how you could use one of the parameters to adjust that.
A parameter. All right, that's a good point. All right, let's take this 0.25. All right, we have to restore all our stuff. Let's go to our scalar parameters and let's give ourselves a single scalar parameter of 1. Right. Now, here's a problem with scalar parameters is that they are not bound. We can see they go up to 1,000, and this is only a value between 0 and 1 by default. So it goes negative 1,000 all the way to positive 1,000. So if you're going to do this, you got to be very, very, very careful. You don't want to grab this and start dragging it because it won't do diddly. You'll be like, you'll have black when it's 0, and then suddenly you'll move it and it's white. That doesn't do us any good. So, all right. So what we're going to do is just change this 0.25 to, I think we're just going to set it to x1. All right. So now that box step is being driven by x1, which is 0 currently. So we're probably going to wind up with, I think, white. Although it didn't do white, which is weird. Let's see. There we go. It might have just not seen it. So 0.1, it's not doing anything. 0.2, I'm just scrolling up slowly over this, and we can see 0.2, we get a couple little black dots. 0.3, we get more black dots. 0.4, we get more black dots. And these eventually, 0.5, we should wind up with a 50%, and then we start going in the opposite direction where there's going to be white speckles and smaller and smaller white speckles. So we kind of go through Jersey cow mode, so to speak, in this. And that can be really useful. This can be really, really useful. And mind you, these steps are just, this is only this is using 0.1. Even because it's a floating point, we could do like 0.001, make this take 1,000 frames, and it would go very smoothly from one to the other, very quick, cool. But there's more to that. That's one way we could use the x1. But here's another thing we can do. We could also just simply put in something like a noise. And so because we have also defined $p, which is a fantastically useful thing because, well, for example, let's go back here. Let's actually set our thing to 0.5. $P is going to be aspect ratio correct for Natron, because that's the way we built it in here, so that it will, when I made our $P, I wanted it to match what we see outside of the, inside of the Disney editor as close as possible, but scaled up. So what we can do is replace this entire chunk right here inside of this FBM. I want to make sure I get everything. Right here, I want to remove all of this and change that FBM from all that code right there to, by the way, remember we don't have to use the $ in front of the P inside of Natron, so all we have to do is put P and it will still function. So now here's P, and this should first scale this. So this is what's called P scaled. I don't know exactly what P is other than the default, you know, scale of the Disney editor, so what you see in the little window. But the nice part about that is that we can scale it up or down by just multiplying it times something. So we could say times, I think if we scale it and multiply it something big by a bigger number, so if I say it by times 2, it makes it smaller. P times 2, let's just verify this. Yep. So if you multiply P times an integer or a whole number, or a larger than 1, because you could also do it by 2.5, it will make this bigger. But if we do it in sub 1 or like 0.5, it'll make it smaller, just so people remember this, so that they know that this is not limited to P is not limited. It just gives us a great start. P should be thought of as our starting point, so that what we see in the Disney editor translates directly into Natron, so that vertically it matches the pattern we see here. If we use P inside of the Disney editor, will match inside of Natron no matter what resolution we're at. That's the goal behind it. All right. But here's a little thing. What if we change this x1, which is currently just a straight floating point value, to an actual different thing other than, right now it's just a number. What if we use something that is actually a floating point image? Like, say, let's just show what happens if we do another FBM. For example, if I do FBM, parenthesis P, parenthesis, just like that, so we have it twice, what do you think is going to happen when I move my mouse out of this? Anybody? Mr. Thomas Morley?
Fractal, I don't know. Look, that's all that comes to mind, is that some sort of fractal looking thing.
We're going to get a color. We just get a solid color. Why? Because every threshold it matches every threshold. So it's always going to be at the threshold or higher, which means it's always going to be above the threshold, which means it's going to be whatever it happens.
Even though it's a million different calculations.
Yes, it's a million different. It's a dumb way to get a solid white image. So for this box step, putting two FBMs side by side is really dumb, and doing that with any form of step system is dumb. So we really want to change. We could do it if we've changed the pattern, but we're using the exact same pattern for both of them. So it's going to
do it times 2 or plus 2 or whatever.
All right, we could just do.
Let's see what it looks like.
We can do a P times 2. All right, we'll do the second one is P times 2. And this
is one of the great things about it being an editor. You can play around and you get what I call happy mistakes.
Yes. Oh, absolutely. This is all, this is happy mistakes. Now, here's the thing. Right now, what we're seeing isn't that necessarily that impressive, because it is just this, trying to think of the best way to describe it. This is box step is not, it's a 2-parameter thing.
Right. It's black or white.
We're really doing an FBM times of an FBM isn't going to give as much interest, in my opinion, as, if we took and changed
FBM times an FBM.
Ooh, well, let's try that. Let's change that instead of a 2 to a CFBM. Now, maybe that'll give us, I don't even know. Whoa. Well, that definitely changed it up a bit. Wow, that really, that's interesting. Or here's another option. Let's change it to a different thing, like NORSE. Noise. Let's do noise versus FBM. Now what we've wound up with is, instead of having an FBM pattern, we're combining two textures at the 50% mark. So this is actually an FBM that is influenced by noises, or that's influenced by noise. So it's less FBM than it originally was. It's got a bit more of a noise pattern to it. So that's kind of cool. And we could, layer this just like anything else.
But you can play in this. It's a sandbox that you could play in, and that's the great thing about all these editors, is that you can just find out these functions and just start mixing them up and getting all kinds of really cool, strange patterns.
That's very true. That's absolutely true. It's one of the fun things. It's just like a lot of stuff. I do want to show or throw out a quick question to you. So let's say you wanted to do do you have any idea how we might take, say, make a wavy pattern like a
sine wave?
Well, not necessarily a sine wave, but a gradient. I'm not going to actually make the gradient inside. You know what? I'm going to copy something from another project.
That code you've got right there, will that work with smooth step too? Could you just replace box step with smooth step?
I think smooth step has one more parameter, which is I think it's a blender or something like that. It's an extra parameter, because smooth step can also do inversion inside of it for the smooth, which is weird. Here, we'll try it. Smooth. If we change this to smooth step, let's see. Yep, it's saying it's too few arguments, because I believe it's looking for something like it wants an extra floating point value as a blending point. So now this is going to create something really weird, and you can see that it's probably produced something, and everybody's going, "What the heck is going on?" We've got hard patterns in some places and soft patterns in others. And
that's cool looking, though.
Yes, what it's doing is that when things fall below the threshold, they're smooth, and when they're above the threshold, they're not smooth. And so we wind up with this pattern where we're getting a combination of the two blended smoothly, and then not smoothly above the threshold. I believe it is. It's very weird, and I'm not going to try and go into that in this particular one, but what we're going to do right now, just quickly, because I want to throw out something, is this might be of something I thought some people might want to do. Oh, what the heck! I'm gonna show a video here inside of. For a minute, I thought the live stream stopped. I want to show a video that was technically part of today's goal. I hope I do this right. 1 second. There we go. I'm going to click this, and this, it's not a perfect thing, but it's a little interesting bit. All right, and it's probably done. So I'm going to go back to you and me, for just the two of us. So we're chit-chatting back and forth, Mr. Morley. Once you've watched it, let me know.
Okay. Yep, it showed up. Nice little wavy pattern.
All right.
Water filling up the Natron.
Right. That was created partially using an SeExpr box step. Okay. Instead of most people, we've talked about creating distortion, edge distortion inside of using iDistort and STM maps and so forth. But I thought it would be fun to try and do edge. One of the big things that we face, we already saw that if we change this, let's put this back to I need to, of course, pull up our Natron. Let's go back to Natron here for a second. And if we go back to, let's get rid of this. So let's put this here and change this back to, instead of smooth, change it back to box. I don't know if undo would work on that, but I'm not going to mess with it. We're just going to pull it up. So we see this, and we see that if we set this noise, instead of noise here, we set this to just a number like 0.5, we get this pattern right here. But how could we, do you have any idea how we might take this and apply it instead of to make this so that this FBM applied to a shape or something?
An image.
An image.
You can input an image.
Well, I'm going to show you something interesting here, which is I'm going to take a ramp. I'm going to copy a ramp from my other project over here. Copy it. Hopefully it pastes in properly. Looks like it did. Let's just take a look at this ramp quickly. You can see it's way up at the top of the screen. Now this is the actual ramp that's inside of that project that we were just, or that video that we just saw. And I took that and I put it into the SeExpr input number 1, like so. And what this, if we think of this image or this ramp as an amplitude map or an application map, we're going to be using this to set the parameters. Anything below this point is going to be black or a color. It's probably actually going to be white if we do this right. Anything above the 50% threshold is going to become it's going to change to either alpha or a color. So depending on how this adds and subtracts, it should go back and forth. So if we go to our SeExpr node here, and right now it's not showing anything because we have not told it what we want it to work with. Well, instead of 0.5, what if we tell it that we want it to work with CS? We'll put 1 for the time being so that we're specifying it. We don't really need to put the 1 there if I recall correctly. But lo and behold, look what it just did to the edge of, or it created this thing, and it's using our FBM pattern to create this like wavy pattern here. And if I pull this down, I can pull this down and make that much bigger, and we get more of the pattern. But by default, if I go back to my ramp, I want to go back. I don't want that. If I have it up like this in this very narrow point, what this opens up is this means I could animate this FBM in some form to make it move over time and thus create waves. So let me just pull up. What I did is inside of my version of Natron, or my other project over here, I actually added a thing. I wanted to actually treat the inputs of this SeExpr node as literal layers. So what I have here is I said CS1 is going to be called, for our purposes, L1, for layer 1, because people like to think of things as layers. So layer 1 is our ramp. So if we take that, and I'm going to now do something really, I'm copying in a very big box step thing. Copy. And I'm going to paste it in here. I have this box step FBM, and we can see what I've done is I got this FBM, and you'll see really what I've done is I've broken down the elements of P. I set it so that P, I took the first parameter, because P, remember, is a 3-axis vector. It has 3 parameters. It has an X, Y, and a Z. Because
we're not seeing the code.
Oh my goodness, you're right. I just pasted it. Thank you very much for pointing that out. That is partially because of this, and partially because of my big ugly mug down below. Nobody wants to see that. Let's shrink this down so we can see this. All right, so we should be good. All right, so here's the as I said, L1 equals CS1. That's our layer. All right, and the semicolon, we put the semicolon at the end to say that's a statement. That's assignment. That's why we have all these things. We're assigning. When we don't put something, that's the end. If I added a semicolon here, this shader would break. but we can see we're getting wavy patterns up here. So this box step, what this is doing is we're taking an FBM, all right, and in here we have this between that bracket and, let's see, I've got to look here, squint a little bit, and this bracket right here, we have P0. So the first parameter of P, because P is a 3-vector thing. It has basically the equivalent of an X, a Y, and a Z. So the first parameter, P0, is getting multiplied by 2 point, technically 0. I just left out the 0 because I don't need to add the 0 to keep it floating point. I just need the decimal point to turn it to a floating point. So I've shorthanded it. And then I've added a plus x3. All right, so what does that mean? That means obviously I have a scalar parameter here that I can do an x3. And this x3 variable will be this position, the x position of where these waves are. So I can move them back and forth, right and left. And you saw that in the various layers of the different colors of water. What I did is I just moved this, you know, like, for example, 200 or 2000 even. That'll work just as well. We'll watch this parameter, and when this updates, after a second or two, this whole pattern changed because it's been moved 2000, you know, pixels to the right or left. All right? So that's what that plus x3 does here. This is our parameter to push it side to side, so we can make 3 different wave patterns just by editing x3. Then we have then we have a comma, which means we're done with the x parameter. So parameter number 2, which is the y parameter, is p1 times 1.0. And the reason I do the times 1.0 is, remember, we said before that by multiplying the p value times a number, we can scale it up or down on as a whole, or if we do it on each axis. So on this, I've multiplied the x-axis times 2, so it's there's twice as much detail on the x-axis, but only 1 unit of detail on the vertical axis. All right, so that's why it's times 1, plus frame x1. All right, so this, what is that doing, the frame x1? Well, frame x1 is a vertical speed. So every frame, it's going to increment, it's going to multiply the frame times whatever x1 is. Currently in this, our x1 is 0.5, which would be probably pretty fast. I'm going to pull up my original one, and I think, yes, my x1 in my original was 0.004, which is pretty slow. That makes it move up, though. It'll make the whole pattern move up over time. All right? So that's making the pattern increase in height. I believe it's moving up. Should be moving up. It's positive. I always think of positive as up, but it's hard to say with a... Anyway, it moves it in one direction or the other. So it changes over time. So this is probably everybody's thinking to themselves, oh, so that's why on this other thing we have a comma after it. We'll see that it's... So that's moving it only... This is pixels. When we do, we take the P1 and we multiply it something and then we add to it. That adding at the end is... Adding in math happens after multiplication, so order of operations says that this stuff here, which is inside of parentheses because this is also multiplication, this will get added to this after this multiplication over here. I actually thinking about this, I don't think I actually do need to worry. That would happen anyway. Anyway, whatever. Not going to argue. I did it that way. Or like specify my order of operation. Anyway, it clarifies it a bit. So then we do have another comma, and then we have frame times x2. So x2, obviously, this is for the z, which is, as we know, is the pushing in and out. That's the speed of pushing it in and out. So for the speed, what I had set it to is 0.0. For x2, I set it to 0.025. And that would set that. And that will make the whole thing, if we were to actually drop this, I'm going to make this really fast because we don't want to wait for this to update. I'm going to just make it really low resolution. Hopefully this will play back in almost real time. We can see that... Oh, did you drop, Mr. Tom Morley, your audio level just, I think, dropped down on... Oh, there it is. It came back.
I had to cough, so...
Oh, I got worried for a minute. I was like, uh-oh, I hope I didn't just lose him. So we can see this is what this is doing is it's basically animating our texture over time. And while this is very low resolution, it gives us an idea of what's going on. And then all I had to do if to animate this is I put a transform node underneath it. I colored it, using a color map, and then I did it 3 times and merged it all together. So I wound up with boom, boom, boom. Whoop! Oh, that's not going to show correctly because it's my screens are actually bigger than 1920 by 1080. We can see here. This is the. I'm going to hide you for a minute so that because you're blocking. Sorry, Mr. Tom Morley, you gotta go. I've just put you off the screen. You're not gone. You're vocally here, but you contribute vocally, but you can't be seen. So all right. So here we can see that quickly that what we see is that we basically have 3. These are the 3 things that went into it, and basically they go in. These set up the thing, the motion of the waves. These here, all this is a solid with a color on it. We can see it's a color. This is light blue, this is a medium blue, and this one is a dark blue. And it merges over using in. So if we go over here to in, we might see this. Let's see. It's going to take it a second for this to update. You know what? I should probably drop this back down to say 8. There we go. And we're going to set that so it's low res. So we can see over here, it's behind my head a bit, but we can still see a bit of it. We can see what it's doing over here is it's created blue. Now, I just want to point out the black area is actually transparent. And the reason that it's transparent is because I took this solid and I told it I want to be the solid to be in as a merge feature that SeExpr result. So this is our result from SeExpr. This is my color, and I tell it I want to be that color to be inside, and it puts it inside, and it does basically the same thing for all of these different ones. And then what I have here is 3 different transforms that were all offset at different speeds, and they all get combined together in this merge node. And this merge node has our text coming in as a mask, and then it has a constant set for the background. And that you'll notice the constant. Why am I doing the constant here? Well, the reason that we're doing the constant here is that these, when they're moving up and down because of the transform node, it's changing our ROD so that it's much bigger than what it actually is. So by putting in this, I'm basically using this constant to crop it back down by setting the bounding box of this merge over. We've gone over this in the past. I set it to B, which makes it merge over, and use this constant which is set to default, which is 1920 by 1080. That sets our bounding box resolution, so it only outputs our image, or the bounding box of the whole overall thing, aka the crop, to HD, so we don't have to futz around. Because I'll tell you what, I've had the crop node used to drive me batty. Crop node for some reason doesn't always crop. You tell it crop, and you still get the RODs. It's still, when you output it, it doesn't output right. This always works. This is a 10 times better way of cropping. Since I found out that, I was like, oh, this is so great. So I use this all the time. Very handy with cropping. This is basically our crop. This is setting our crop. All right. So then we come down here to our card 3D, which of course does a little zoom at the beginning. I don't know if you caught that when it zoomed in. That's what that card 3D is. And then of course, this over here is our ramp background blue. You could add in bubbles or other things. I didn't want him to get overly complicated. And then we, of course, superimpose this over it because this is, of course, transparent. And so it goes over it and we get our thing. And when it goes through time, we get our various points of, there we go. You can see it here partially, I don't know, it is showing a little bit of it. I'm going to push it up and over so that my face isn't blocking it. We can see the results here, and that is how this effect was created. And I'll probably elaborate on this a little bit more. Anyway, we are over an hour at this point. This is an hour and 15 minutes at this point. So I'm going to pull you. I'm going to actually now. I'm not going to pull you back in. Edu, won't you, in this particular... Actually, you know what, because we have one more thing we need to do.
I'm very curious on if you switch back to the Natron that you have. If you replace that ramp with the text, what would that look like?
If I replaced the ramp node with a text node?
Text and what you coded
I'm not gonna do that. That's something, if people want to mess with it, mess with something like this, they can build this. Actually, I'll probably just,
not this one here, not the complicated one, the simple one.
We'll
do that offline.
Okay. All right. We'll do that last thing. All right. Let's put a text in here. It's not going to do much. Well, it will do something.
Will it just do the top and bottoms of the text? I guess that's what I was just curious. Will it only do the top and bottoms of the text?
It's probably going to look like either text or, inverted text. It's inverted. It basically created inverted text. It looks weird here because I thought, let's do center interact. Oh, this is really getting...
You're going to zoom in, size it larger.
Let's set this up to like 200. So the enter text is bigger, so we can see it over here. And let's turn off the overlays. It just inverted the text. And the reason that's happening is because we are doing a box step. And remember, we're dealing our two variables, or our thing that sets the parameters for the where it's going to happen. One of them is hard. As long as one is hard, that means the 50% point is exactly at the transition point. So we're going to wind up with an exact transition. Now, if you put a blur in here...
See, and what I was thinking of, how you always see flame text. Is there a way that we could use the box step or...
That's an interesting point. We could potentially...
Like flames on the edges of it.
We can blur it. I don't know if I've blurred it too much. I should probably look at it here. Let's go back here. This is, just so you know, this is it seems to be a lot more time consuming than I had originally expected. We're getting, you know what, let's make the text a bit more, let's make the weight ultra heavy. That always makes it much more, gives it more meat.
You can see a little bit of stuff going on there, but maybe the FBM is too large.
It could be that the FBM
the size down. Yeah,
could be that.
More to follow.
Yeah, let's.
Now I'm going to dive into this for sure.
Oh yeah, well that's the whole point. This is all about getting people. Let's just do. Well, I don't want to actually. Now that I'm thinking about it, I don't want to get. Yeah, this FBM. Actually, now that I'm thinking about it, this is way too loose an FBM because I've also, I think in here, did I change the FBM? Yes, I did. Here, I changed. You can see I changed also the defaults. The two defaults, the lacunarity. I think that's how it's pronounced. And also the octaves. So the octaves is 2 as opposed to 6. And, well, the lacunarity is actually 2, which is the default. But if I set this back up to 6, it's probably going to... It might change this a little bit. It's going to take it a while. This is a very, very complex because it's doing a lot of math due to all this here. It's got to figure out our frame, do the math against things. This takes actually quite a while, a lot longer than I had originally hoped to do. And it really didn't do much. We'd have to do. This is something that people should play on their own. Exactly. And we're up to an hour and 18 minutes. So this is really running long. But we must do one more thing, Mister.
We must.
What must we do? You know the answer.
Fire the cannon.
We gotta shoot Natron. Why?
Because we can.
Take that, Natron. Take that. For all the times that people run into some frustrations with you. Anyhow, we're coming back to the two of us.
Super solid today, though. We got to give Natron a thumbs up.
Natron's been great today. I wish we had a little bit more feedback from others and interaction. I'm just going to pull. Whoops.
Well, that's what we're reaching for, right? We're trying to pull a little more from them.
We're trying to. Well, that was people said they want us to in the comments. I did a poll the other day, and people in the comments had said, "Oh, we want to interact more with you." You know, that's what the whole point of doing live streams. And I'm like, okay, well, we'll try and get more into interactive stuff, and it helps when I have somebody working with me. So, you know. Anyway,
glad to be here.
Nobody actually. Oh, I wish to say to my public, you know, actually there's people here, but they're not quiet. They're just like, he's talking.
Oh, wait a minute. They're asking for feedback.
That's right. Anyway, it's all good. It's all done. Thank you for joining me, Mr. Tom Morley.
Always a pleasure.
And you're a gentleman and a scholar, and if I had my Esquire bit up, I would hit the Esquire on there and put up your an Esquire as well. So, anyway.
It's been fun.
Yeah, thanks for watching. Keep all Natroning.
Natroning.